Okay, guys, so for tonight's video, we have three learning goals I'm going to go into tomorrow. So the first one is I can interpret the vertical intercept of a graph of a real-world situation. I can match graphs to real-world situations they represent by identifying the slope and the vertical intercept. And I can use patterns to write a linear equation to represent a situation. So first, in order to do all this, we have to define what a vertical intercept is. So the vertical intercept, this is also a lot of the times in my class going to be referred to as the y-intercept because the vertical axis is the y-axis. So it's also known as the y-intercept. So you can go ahead and write that down here, y-intercept. The vertical intercept is the point where the graph of a line crosses the y-axis. So it is where the line crosses the y-axis. Your y-intercept or your vertical intercept is where the graph is the point where the graph crosses the y-axis. So some facts and characteristics. We've got two. Is this point is the y value when x equals 0. So every time x equals 0, the y value is going to be your y-intercept because the y-axis is where x equals 0. The other fact is in proportional relationships, what we were working on last week, proportional relationships have a vertical intercept of 0. That is what makes them proportional. So we already know proportional relationships start at 0, 0. Because it starts at 0, 0, that y-intercept, the vertical intercept is 0 for every proportional relationship. So an example would be something like this. Whether our line is increasing or decreasing, this point right here is the y-intercept. Okay, so this line is decreasing, but again, if my line was increasing, where it hits the y-axis is your y-intercept. A non-example, and something that many students get confused, is, let me draw a better graph than this. Let's do a 4-quadrant graph. I'm going to do an increasing line here, but this point here, this is your x-intercept. That is different than your y-intercept. This is the x-intercept. So this is a non-example of our vertical. So there is x and y intercepts. You guys will talk about both in algebra, but in 8th grade, our main focus is the y-intercept. Okay. So now that we know our vertical intercept, we can go and look at real world situations. So Omar and Irel decide to save some money they earn to use during the school year. Here are graphs of how much money they will save. After 10 weeks, so the graph goes all the way 10 weeks, if they each follow their own plans. So how much money does Omar have to start? So we want to look at Omar's line. And to start at 0 weeks, Omar's line is at 20. So the y-intercept, the vertical intercept, is always your starting amount. You want to think of it as your starting amount. So Omar starts with $20. Next one says, how much money does Irel have to start? So we're looking at Irel's line, and Irel's line hits $10 on the y-axis. So the vertical intercept for Irel is $10. How much money does Omar plan to save per week? So saving per week, this is asking about the slope. So you want to find the slope for the line. That is going to be your unit rate. So if I'm looking at Omar's line here, I can pick any two pretty points on here. And I noticed that Omar is going up. If I look at this example, it's going up from 50 up to 60. So that's going up $10. And from this week, this is week 3 to week 4, that is 1 week. So that is $10 per week. So Omar is saving $10 per week. How much money does Urel plan to save per week? Again, this is the slope for Urel's line. I'm finding 2 pretty points here. So if I pick these 2 pretty points, I can see this point is at 50, this point is at 70. So from 50 to 70, it went up $20. And week-wise, that's from week 2 to week 3. So that is 1 week difference. So the slope here is $20 per week. So Aurel's planning on saving $20 per week. So Omar starts with more money, but because he's planning on saving less per week, Aurella starts saving and having more money saved than Omar by the end of the 10-week period. So this says, how can you find the vertical intercept and the slope from a graph? So to find the vertical intercept, look at the value where the graph intersects the y-axis. So wherever the line hits the y-axis, that is your vertical intercept. To find the slope, this is what we are used to doing. To find the slope, look at how much the y increases when x increases by 1. So your slope is just saying how much the y value increases every time x increases by 1, similar to the table that we did in number 3 of the warm-up. If you guys have any questions or anything, please let me know. And make sure that you guys have this ready for tomorrow, as you will have an entrance ticket on these notes tomorrow.